All right, today we are diving into something that is genuinely a game changer for AI. We're going to talk about a new technique that might just be the key to letting AI understand truly massive amounts of information. I mean, think entire books, huge legal cases, all in one go. This isn't just about making AI bigger, it's about making it way, way smarter. Let's get into it. So here's what we're going to cover. First, we'll tackle the big problem AI has with memory, what we're calling the memory wall. Then we'll get into the simple, almost elegant idea that solves it. From there, we'll look at the breakthrough itself, see how it performed in some pretty amazing tests, and then we'll wrap up by talking about what this really means for all of us. Okay, first things first, we have to talk about the hurdle. Even the most powerful AI models you hear about today have this, well, it's kind of like a short-term memory problem. It's a fundamental wall that researchers have been running up against for a long, long time. I mean, it's a ridiculous question, right? You obviously can't do it. There's just not enough space. Well, believe it or not, that's almost exactly the problem that large language models are dealing with. They have this thing called a context window, and you can pretty much think of it as their sticky note, their working memory. And this really shows you the difference. You or I, we can read an entire library over time, connecting ideas from different books. An LLM, though, it's stuck with what it can cram into that one context window. And the reason for this isn't random. The amount of computation it takes to process more text just explodes exponentially. So eventually, it just hits a hard wall. If your document is longer than that window, the AI literally can't see the whole picture at once. So, how in the world do you teach an AI to read an entire library? Well, the solution is surprisingly clever, and it's built on a concept we all use every day when we face a huge project. You break it down into smaller pieces. Let's use an analogy. Imagine you're the head librarian. Your boss asks for a summary of the entire library. It's an impossible task for one person. So what do? You delegate, right? You tell your junior librarians, hey, you take this bookshelf. You take that one. They each come back to you with a simple one-page summary. Now your impossible job has become much, much easier. All you have to do is read and combine their summaries. You've just solved a huge problem by breaking it into a bunch of identical, smaller ones. And this whole process actually has a name. It's called recursion. It's a super powerful idea from computer science where to solve a big problem, you just have a program call on itself to solve a little piece of it, and that is the insight that's letting AI smash through that memory wall. So let's connect the dots here. Researchers have taken this exact idea of recursion and applied it directly to language models. And in doing so, they've created something totally new. They call them recursive language models, or RLMs for short. And you can think of it exactly like our analogy. The RLM is the head librarian. When it gets a document that's way too long for its context window, it doesn't just error out. Nope. It basically becomes a manager, calling up copies of itself, the junior librarians, to go work on all the smaller chunks of the text. So here's a little peek under the hood. The RLM sees a massive document not as one giant wall of text, but as an environment that it can actually explore. It then programmatically breaks that environment down into manageable pieces, makes those recursive calls to itself to handle each piece, and then at the end, it pulls all those little answers together into one single coherent response. Now, all of this sounds fantastic in theory, right? But the big question is, does it actually work in practice? Well, the researchers put it through its paces, and honestly, the results are just staggering. This is not a small improvement, it's a massive leap forward. Let's just start with this one number, the new recursive model, which is called RLM QN38B, performed, on average, 28.3% better than the original version of that same model on these long document tasks. You have to understand, in the world of AI research, a performance jump that big is, well, it's huge. And this chart just makes it crystal clear. On the left, you've got the base model, which is already a pretty darn good model on its own. And then, on the right, you see what happens when you add recursion. The difference is just, it's undeniable. This recursive method unlocks a whole new level of performance. Now, this is where it gets really interesting. This model, which is fairly small by today's standards, started performing so well that its quality began to approach that of the giant frontier models, the next-gen stuff, especially on tasks like summarizing massive documents or analyzing complex code bases. That's a wild increase in efficiency. And here is the big headline. With this method, RLMs can process text that is up to 2 orders of magnitude longer. That's not twice as long, that's 100 times longer than what the original model could even look at. To put that in perspective, it's like going from an AI that can maybe read a chapter of a book to one that can read the entire trilogy, understand it, and answer questions about it. So let's zoom out. What does a future with AI that has this kind of memory actually look like? Because this discovery isn't just for a lab somewhere, it has some really profound real world consequences.
For developers, this is a brand new tool in their toolbox, a cost-effective way to build apps that can handle huge amounts of text. For researchers, it's a huge deal for inference time scaling. That's a fancy way of saying making models more capable when you actually use them without having to do expensive retraining. And for all of us, it opens up the possibility of AI that can truly understand the full context of a patient's entire medical history, or a company's complete financial filings, or a very, very complicated legal case. This really is a fundamental shift in what AI can do, which kind of leaves us with this one final big question to think about. When we finally have an AI that can read anything, hold it all in its memory, what's the very first thing we're going to ask it? Thanks for tuning in.